Gravity simulator working, wrote it about 2002, and quite interesting running on a MacBook Pro purchased in 2019. It requires an older version of Java, version 1.8, so there's a bit of a trick, but once you've got that set up, it all works, and it actually works in 3D. It's fairly naive numerical implementation, but quite fun. So here, for example, it's set up to create 1,000 random objects. All of them will have this identical mass, and the velocities will be random in the XYZ directions up to a maximum of 50, I think, any of those directions. It just does uniform random sampling, and you hit random over here, and it again, the actual positions are random as well, so they end up in a cube, and you can actually rotate it and see, and you can reset the view over here, and just pressing Alt and dragging away from you zooms out a bit, and then we can actually so if the default animation rate comes up quite a bit lower, but on a modern CPU I can set that to about 200. It's not multi-threaded, so having multiple cores doesn't make any difference, and we're ready to unpause the simulation and see what happens. So those random parameters I had for the velocity and so on, if the velocity is lower, it obviously doesn't have enough energy in the system and it just quickly collapses. If the velocity is too high, it just drifts away. But this is a moderately interesting simulation. It just uses a simple Runge-Kutta 4-5 solver with no adaptive step size, so you can control the step size over here. What's quite fun is if you set that to a negative, it more or less runs backwards. So it's pretty much simple Newtonian gravity, n squared, so n particles. The gravity force is calculated against all the remaining n-1 objects, and the thing that inspired this was to try and work out why galaxies rotate. So that initial cluster just has all the particles moving randomly. One thing that is interesting, there is on the command line a display of what the angular momentum is of the system when it initiates, and with all that randomness, it always actually does end up with a net angular momentum, so a bit of work would be needed there. So never quite achieved its original goal of working out what happens if you start with zero angular momentum. Do you end up with a whole lot of particles moving away? Now what's happening is some of the numerical errors kicking in. So being Newtonian gravity, 1 over r squared, once r gets too small, the force it calculates is numerically overflowed, and I'm not sure exactly of what the details is, so you see a whole lot of what looks like little explosions. One thing I must mention, I was trying to counteract that, so whenever two spheres intersect, there's actually a very strong friction force implemented to try and prevent the origins of the centers of those spheres getting to zero distance or close to zero distance. But when there's enough particles and they compact in a dense space, as you can see around here, that doesn't help, and so you actually get those numerical explosions, which is why particles fly off like that. And as I said, you do actually end up with rotating systems, but that's pretty much because the randomness isn't high enough in the beginning to actually start it out with a net zero angular momentum. So quite fun to play with. There's a few other things you can actually do with it. It's really just a toy. You can actually set the force. If you say switch force over here, you can set it to be such that there's a spring force which tries to keep, which has a zero force at a certain constant distance between all the particles. So it tries to keep each particle an exact distance from all the other particles, and those tend to be quite fun simulations as well. You can actually run the exact same code base in a 2D mode, and it renders everything in 2D mode, and then you can interactively drop objects on to the screen. You can actually use this user interface over here to drop things on as well. And I should just note that this is running on the latest version of Mac in May 2019, and when you open these screens, they actually need to be resized, otherwise they don't render properly. Something to do with high DPI, I guess, and the layout manager's just not quite working the way they did 17 years ago. But yeah, just a bit of fun, and I was quite amazed that I could actually get it working again after all these years. Last time I got it working was about 4 years ago, but since then the latest Java versions don't actually run it. They pick up some memory accesses that shouldn't be allowed, the slightly older Java version. So this is running on Oracle Java version JDK 1.8, and that was installed. Basically allowed myself to easily switch between Java versions using Java, and I'll probably document that on the README and put it up on the GitHub site. But yeah, it was just good fun to see it working again.